everybody hear me okay? Yeah? All right. So like she said, my name's Candace Guerrero. I've been the assistant director at the Center for Metabolism Proteomics for about the last 2 years now. Before that, I was manager. I've been working in the core facility for about 10 years now, on and off. So today I'm first just going to introduce you a little bit about CMSP if you're not familiar with them. So CMSP was established, or the Center for Metabolomics and Proteomics was established in 1999 with a couple of staff members that did mainly proteomics. And over the 24, 25-year stint, we have now done proteomics, extended our staff to 10 people, and now we do quite a lot of metabolomics too, as the interest is kind of grow. So our sole purpose at the University of Minnesota is to help investigators with all their experimental needs related to biological mass spectrometry. And then we also take the opportunity that whenever people would like to develop a mass spectrometry-based skill set, we could take the opportunity to train you on sample prep, method development. So in molecular biology, there's a ton of omics applications that you can do. There's a lot of researchers out there that want to approach human physiology from multiple omics standpoints. Our lab is basically focusing on proteomics, metabolomics, and some lipidomics. So we're here to offer you any kind of needs that you have as far as that. Proteomics is initially our bread and butter on what we do, but over the last, I would say, even 10 years that I've been here, there's a lot of interest in people understanding the metabolome and its relationships to human physiology. So over that course of time, we have developed new unique assays, routine assays, and so forth. But there is still like a general need to have kind of some global coverage of metabolome, and it's not always so easy to do. All right. So when you look at human health and as a continuum, you start out very healthy, but over the time your lifespan, you end up progressing. You may come up with some diseases, you may have cancer, so forth like that. Obviously, you can take this research from the standpoint of genomics, transcriptomics, or proteomics, but whenever we're looking at the metabomics, we're looking more for factors like related towards like prediction, early detection, and diagnosis of maybe, certain types of diseases or just understanding. And when we can do that via like the metabolomics, we can sometimes develop therapeutic intervention or therapeutic responses and ultimately, prognosis. So we are exposed to a lot of different factors every day. It's not our DNA, transcriptome proteomics, but we are also have environmental life factors that can kind of play a role, whether it's food, drugs, medication, certain lifestyle, the environments in which you come from. And it really is kind of nice to get the full view whenever you can look at the genome, the transcriptome, the proteome. But basically, if you really want to have a good understanding about it, metabolites are the functional readout of that phenotype that you're particularly looking for. So there's a lot of interest that's growing into trying to understand those functional readouts and apply it to particular phenotypes. So in metabolomics, you can take relationships between certain metabolites with themselves in regards to disease, or you could take a combination of metabolites and associate them with particular disease states. You may have models in which you're trying to study, inflammation or dysbiosis. I think Chris is going to be studying dysbiosis today, oxidative stress, and all of these we just kind of want to find the connections for whenever we're trying to find indications of maybe immune disease or infectious diseases. So whenever I was first working and I moved towards like the assistant director position at CMSP, I had to kind of realize that what people wanted at the university as far as their research needs and try to like adapt our methodology to kind of fit your needs, right? So in order to do that, We could use, targeted MRM, metabolomics. The problem is that those sometimes take a long time to develop, and you may have a small sample set or you may have a super large sample set, but it's going to take time. We have discovery metabolomics, which is great, but also the caveat is that you have to have a mass spectral library associated with that. We can run your samples all day long and get features that maybe could identify to something, but unless you have a reference theater that is in a library that aligns with retention time and mass spec fragmentation, it's really hard to identify. So when I first saw Biocrates, I looked at it as an application to have a general landscape, metabolomic or metabolite landscape in which people could get a general overview of what their system was doing with regards to conditioning or control situation. So Biocrates 1 is based out of Austria. They have been expanding into the United States. Prior to COVID, they did almost everything in Europe. After COVID, they have kind of integrated, and they have, I think, more than 104 facilities within the United States that actually does Biocrates technology and kits. So one thing that I really love about Biocrates is whenever you're taking it, I'm trained in animal chemistry. So when I take it from my standpoint, I'm looking for a reproducible, robust assay that's very quantitative and does its job the same way every single time. All right. So when you are a PI or a researcher and you do an experiment like, say, month 1, and maybe you have to redo that experiment 6 months later, there are variations. There's sample biological sample variations. There's a ton of different variations that you have to take in consideration. What I like about Biocrates, though, is that they've taken out some of that variation. So which if you want to do an experiment, say, month 1, and then you want to do another experiment, month 6, and you plan to procreate for that, you can take that information, you can normalize it together, and you can use it. That doesn't happen very much in metabolism. So I wanted a kind of a methodology that we could do. We could provide PIs and researchers that could go. So also they incorporate a lot of different platforms. So they have multiple types of kits that you can choose from. And then as well, the biggest thing that I like about them is that you own your data. Okay. So if you go to large metabolomics companies, I won't name them, but some of them only give you an output in Excel sheet or for concentrations, and you don't have the raw data, you don't have the metadata, you don't have any of that information. All right. CMSP prides itself that we've always been very transparent with our information, and it's not ours, it's yours after we release it, and that we kind of help you understand the raw data to the metadata to the process data. Biocrates does that as well. So it was also really interesting to find a kid in the company that kind of aligned with our data release our ownership goals, the data release. So the coverage of the biomarkers in most of these kits, and this is an example of their newest, most broadest kit they have. It's the MXP 500 Quant Kit XL. As you can see, you have about 107 different small molecules that they target throughout this assay. Some of these are absolute quantification, others are relative quantification. And also, if you're wanting to understand the lipid profile, they have a large subset of 25 different classes of lipids that you can kind of monitor for. So lipidomics in itself is a very, very tricky area to kind of perform, and especially in mass spectrometry. So this just kind of makes our life a lot simpler on the back end. You get your hydrophilic small molecule compound, but you also get that lipid profile. So coverage in pathways. When I'm talking about a metabolomic pathway, most multiple reaction monitoring or targeted metabolomic assays that we set up may only be for one type of molecule or maybe one type of pathway, right? But Biocrates offers different types of standards or different types of analytes in their system that works to make like a comprehensive coverage of multiple pathways. All right. So whenever you get your results and you're trying to find either statistical upregulation or downregulation, you may want to do like a metabolomic pathway analysis and see which pathways are actually getting upregulated or downregulated to make sense of, what hypotheses you have toward, a particular disease. And again, that brings up the key benefits of being, it's relevant, okay? There's a lot of different types of metabolites that you can look in using this kit. It's comprehensive, okay? It's not only doing a small molecule or a small subset of molecules, it's doing a vast variety of molecules that you're going to get. It also works with, expanding your understanding. So Metabolite or Biocrates as a company has worked to develop these metabolite indicators that are basically based off ratios of your analytes within that kit that are relevant to previously published research. So this can give you an indication of different disease types or cancer indication. Again, it's standardized. It's translational. Another thing that I like, it can be used over multiple platforms, especially in mass spec. Not every core facility or laboratory has the same instrumentation. It's very nice to be able to take that kit and be like, I'm going to run it on a SciAx 5500 this time. I'm going to now run it on Agile. Okay. It's very versatile in its ability to provide the same information and the same results using multiple platforms. All right. And again, the last one is ownership. You own your data. So that's great. So these are some particular types of kit we most routinely run in CMSP. The biggest one we probably ran the most is the MXP 500 kit. They've just released the XL kit, which added about, I think, 500 lipids to it. So if you're really interested in that lipid kind of interaction with your model, then that's the kit to go for. So it kind of offers you a few different options based on what you really kind of want to look at. So, say for instance, you're more interested in the small molecules. Well, say you could do the MX 500 kit, and if you find that bile acids are upgraded, well, they have a bile acid kit, and now you can just target bile acids in a study. And if you want to look at lipids, you just head straight to the XL kit. That's going to provide you a ton of different information on that. Two, when I looked for different types of technology, especially in the medical department, people have a lot of cohort studies going on, which the sample is not just aliquoted for your use, it's aliquoted for multiple omics uses. So when you're talking about the sample amount that needs to get used, Biocrates requires 20 microliters per sample. That is unheard of for a lab. If I'm going to do an MRM study in my lab for targeted, analysis, I'm probably going to ask you for 50 upwards to 90 microliters of material so I can do that. So this is what's really awesome about it. You don't need much material to kind of do this, especially if you're looking for plasma and serum. Another thing that I love too, it's not just for plasma and serum. You can do stool. We've done urine. We've done cell cultures. We've done a ton of different tissue types in mouse, rat, human models. So it's very versatile whenever you're thinking about the applications that it can be used for. Like I said, it's multiple platforms. It comes in two different kit formats. So say, for instance, you have a large study. Their full kit format comes out in an 80 sample kit. So you can run 80 samples within one labeled kit. They have a perhaps plate format that will fit 40. So depending on what your needs are, they have a couple of options for that. And then two, in Metabolomics, we often look at if we're doing discovery-based Metabolomics. At the end of the day, you'll get a ton of different features, but the actual identification to those metabolites might be low. We're ranging anywhere from 200 to maybe 500 metabolites, depending on what your sample type is. While Biocrates, since it's a more broad targeted kit, we're averaging about 700 to 710 metabolites for plasma and feces, respectively. So it allows you to get more data. It's more sensitive than a global kind of metabolomics experiment as well. So also, they've done a really good job that in samples where you have human plasma, it's kind of hard when you get the results to kind of understand and see whether maybe it can control dish and make sense or not, right? So they've completed databases on human control samples for plasma in which they kind of illustrate and provide you baseline numbers for those metabolites to know whether or not, your control system's making sense. And so I mentioned a little bit about the MetaboINDICATORs. So these are sums and ratios of metabolites and indicators that indicate enzyme activity. So basically, these can be used to indicate disease and in cancer. They can also be used to normalize the data. So basically, it increases your statistical power of an analysis. And also, like these advanced insights to the metabolomic processes and pathways, they ultimately let Biocrates have a deeper biological interpretation of the results. So these are just some examples of these MetaboINDICATORs where you may have like a Fisher ratio that indicates severe liver failure. As you can see, there's these are just 4 examples of how the MetaboINDICATORs can indicate disease in cancer. I just want you to understand that today's point is to kind of show you the different applications that you can use with Biocrates and how already the University of Minnesota and PI and researchers have kind of embraced Biocrates for kind of a point to do large cohort studies on for MedTech. You guys have any questions?